this is Kim. It's good to see you today. So what we're going to talk about is the basic overview of a VCV, the basics of a VCV. We'll cover the basic functionality and the concepts and what actually it is. It's actually really good software compared to you're getting all the modulars by yourself. It'll be really expensive. So it's actually really good for you to watch this video and check this out. Okay, so what it actually is the when you look at the synthesizer, you have different types of modules, right? Like oscillator, filter, LFOs, and envelopes and effects module. So what the definition of a module is a single or very small functioning like really basic functions on one device. So what it means is one device is doing something, just one or like basic stuff, and they're organized in the same functionality. So as you can see here, this is a Midi to CV module. What it is converting Midi data to control voltage signal. So what is control voltage signal and Midi data? First of all, the difference between Midi and CV is Midi is a digital data. CV is a control voltage, which is an analog signal. So what's the difference between analog and digital? Basically, digital is called what we call this a discrete. Discrete is a disconnected. So it's shown as sampled dots. So when we see this, like when you see the sine wave, this seems like connected, right? So this connected signal is analog. But when you look at the digital signal, it actually looked like a dot, right? So if you turn on Ableton or Logic, you can see the dots inside, right? So that's the digital. So what's the difference between digital and analog? It's just the signal is connected or disconnected. So connected signal is analog and disconnected signal is digital. But here is not a digital signal. Midi is not digital signal. It's a digital data. It's a kind of a document that you have a whole information, like pitch CV, like you see all this information. This is all analog signal. It's all analog, continuous signal. MIDI data is like a document when you write down like information in digital format. So what it does is converting digital data into analog signal. So what we are trying to see is if we see the gate here, on the module, if you see the colored boxes, this colored box is actually showing the output of this module. And if it is not colored, it's the input signal. So signal goes into this spot and the signal comes out of this black spot, right? So what I'm trying to do is I'm going to drag gate output to the scope. Scope is basically like when you think of a microscope, right? You're seeing something. It's a scope. Basically, you want to see the signal or like sound, what's going on, right? So on the MIDI to CV section, you can select core MIDI, and here you can select the MIDI device. In this case, I'm using T-Step Pro, and this is a channel, so I recommend you to use all channel, right? So if I press the MIDI key, you see there's something going on the scope, right? And we see this lights blinking up, right? And if I click it, you see the voltage is going up to 10 volt and 0 volt, right? Right? So the gate signal is basically a switch. So when we press the key, it opens up the signal, right? It opens up the gate so the signal can pass through. But if we don't click any MIDI key, it stays to 0 volt, right? You see the 0 volt? And also the good thing about the VCV is it's showing the output indicator and input indicator. So in this case, if I click the output, it's a 10 volt, input is the 10 volt, right? So that's that. So basically you have to remember the gate is basically a switch for the sound. And here is called something weird, right? 1 volt per octave. So what it means is when you see the MIDI keyboard, like you have a bunch of MIDI keys like C4, D4, E4, like C5, all this different MIDI key has a different voltage assigned to it on hardware synthesizer, right? But in MIDI, it's not actually mapped on the MIDI keyboard. So what this device is doing, this spot is doing, is converting each MIDI note to designated, like determined control like voltage signal. And this voltage signal is a kind of a similar to gate signal, but it doesn't turn off. It just stays there. So I'm going to explain why this happens. Think about we are pressing D, right? You press D, you see the line goes up, right? If I play the key, it's going up and down, right? So before we tap into this, we need to know two definitions of the signal type, right? One signal is called DC, which is like gate, like it's on and off, right? On and off. It goes right up, stays there until we release it and we drop it. So this top line is called DC signal, or here it's a DC signal. So why are we talking about DC signal? DC signal means direct current, okay? Direct current means just a line, okay? The line aligned to X axis. And another thing is alternating current called AC. You see it's alternating back and forth and like up and down, right? This is called AC. And we want to see the DC, right? This is just a line that stays there and stays here, right? So when we think about the oscillator, it's something output, right? It doesn't stop, right? So we need to make this a stop, right? So do you remember the gate? The gate was the switch, right? It turned off, and when we click it, it turns on, right? So what we need is to combine this constant signal, which doesn't stop. So it's unswitched, right? And we want to make it to switch. So what we're trying to do is we're looking for the module called VCA. Let's see. Yes, here. VCA. VCA means basically voltage control amplifier, right? So if you see this, it's a CV input, it's a channel input. So on modular, when it is a channel, it means audio signal. And this is the CV signal. The color thing is output. We don't know yet, but it's some kind of a signal out, right? So we're going to connect to the output of the audio module. Also, you can select the output of the audio device. But as you can see, this is a kind of a mono, right? And actually, this is a dual mono if we do that, right? If we do this. So what we want to do is if we click command and we drag it, we have a dual mono signal or stereo signal we can send. But in this case, this is a dual mono. We're going to talk about dual mono and stereo later. So the output is set, but the voltage control amplifier voltage is controlling amp. So it's controlling the volumes of the signal, right? So as you can see this will be audio signal, right? It doesn't stop here, right? But as you can see here, it's called CV signal, right? CV input. On the MIDI to CV section, you can see the CV is all CV, right? It's all CV. Then you might have a question. Oh, this is also output. This is output. How do I know which one is a CV? And how do I know which one makes a sound, right? So in Modular, I categorize these two different signals as an audio signal and CV signal. So CV signal means, CV means control voltage. It basically means it controls the voltage, right? So CV signal means something is controlling something with a voltage. As you can see, this modular in this rack system, any hardware modular or the VCV is all run through the voltage, like the electric voltage, right? So what I'm going to connect is connect gate output to the CV input. Why? Because I don't want to hear the gate sound. It sounds like just like this, right? As you can see, you can hear two ticks. The two tick is because when you see the gate, it goes up and it goes down, right? On the audio signal, if this doesn't have zero crossings, it'll generate pop sound down as well. So it's showing two pop sound here, right? That makes sense, right? Because it doesn't have a zero crossings. It's going right over the zero crossings. So it's not smoothed out, right? So we want to use this gate output as switch of VCA. You see this signal is full, right? This signal is full, but if we connect gate, it goes away, it mutes it closes the signal that's going inside this VCA. Let's test it. If this oscillator is making sound, and we want to mute this, we have two ways to do it. We can lower the volume knobs of the voltage control amplifier, or we can just connect the switch and it goes off, right? Now, if I press key, the sound's coming out. If I take the keys off, the sound goes off, right? So what it is actually the gate signal opens up the signal, close the signal, opens opens up the signal, close the signal, right? Does it make sense? So it's a switch, basically. So when you want to understand this in an easy way, you can think of this as a like light switch. You turn on, turn off, right? But right now, do you hear any pitch information? No, right? We need to connect the pitch information from the Midi keyboard and convert it to control voltage. Those control voltage sending different voltage, the number value of voltage, to somewhere. And that signal is modifying oscillator, right? So what I'm trying to do is I'm going to take the pitch output of the Midi to CV and connect it to voltage control oscillator, right? Right? Now we hear the pitch, right? But we want to know why this is sending a pitch, right? First of all, we want to see this blue line. When you think of a pitch signal is basically DC signal, which means a direct signal is a line aligned to the x-axis. Do you know why? So the pitch information is determined by the values of a y value. But if this pitch information is alternating, right? Then it goes from C to G to A to like it's gonna go up and down. And the pitch is gonna wow like it's gonna move like that, right? We don't want that. We want to have a straight lines of a pitch information, right? So that's why this information is a DC signal, right? It goes up, it goes down, right? Straightforward, right? So we want to have this steady pitch information, right, into the oscillator. But before we tap into this, let's look at this one, okay? Let's look at this one. So we are converting the Midi keyboard location information, pitch information to voltage. And that voltage is a static signal, DC signal. And it's going to send those static signal to oscillator, right? It's gonna be stuck here. It's gonna be stuck here. But it's gonna be stuck here. Why? Because if we click the keyboard and if we lower the key, if we remove the key down, like if we take our hands off from the keyboard, if this signal goes to 0 volt, what happens? The pitch information goes back to 0, and those difference, the signal difference, the movement will be shown and sending this signal to like it goes up and down. That's gonna happen. We don't want that. So we want to stay there, which means this location, this voltage is basically latest location that we have pressed. Okay, so let's hear the sound. Now we hear the sound, but it's not turning off, right? It stays there, right? It's stuck there. So what we want to do is we want to put the switch on it, right? It turns off. But here's a problem. Are we going to use this clicking sound on the front and back. We don't want that, right? So what we need to put is a envelope module. So on the envelope module, it's called ADSR. Where is ADSR? I think, yes. So EG means envelope generator. There is a function generator and envelope generator, and we are going to cover that later on. So what we want to do is this thing is also CV control module. CV control module. So it's a controlled by CV. And I didn't explain about no, I did, yes. So CV basically means it's a controlling something. So it's if we want to control pitch, if we want to control octave, if we want to control the frequency, if we want to control other things, it's all CV, right? But if we want to hear the sound, that will be the audio signal. So audio signal is basically CV signal, and CV signal is also audio signal. Both are the vice versa. But the only difference is the usage, your intention. When you're trying to use that to control something, that comes as a CV signal. But if you want to hear the sound, then it becomes audio signal. So what I'm trying to do here, we have an audio sound going here, right? It's alternating, plus minus, right? So we want connect the CV output from the Midi to CV module, right? It's the switch, right? And we want to trigger this shape of envelope generator during the gate is on. So when the switch is on, this envelope shape will follow the shape of a volume line, right? So this envelope tab will connect to VCA. You see? Now it seems like an instrument we have used. Like I'm going to use short attack, slight decay, sustain, and short release. Yes, now we have the instrument. And you want to understand about this thing. So modular is basically monophonic. Monophonic means it's a single signal, like single voice. Voice means a note at one time. So monophonic means you're playing just one keyboard at a time. Even if you play two keyboards at the same time, the modular will send just one CV signal. So if you want to make the polyphony, you need another module, but we're not going to cover about that. We're going to cover only about the monophonic, right? Right. So this is basically modular is a monophonic, right? Now it seems like we have built a basic synthesizer, but we missed something. It's called voltage control filter. So basically voltage control filter should be connected to this sine wave from the oscillator should be connected to filter, right? And this filter is going to connect to the VCA. So, right? So what we call now this 7 module, we build a synthesizer, basic synthesizer, we call this subtractive synthesizer. Subtractive synthesizer is basically a synthesizer that includes a filter. So filter is sorting out the sound. It is removing the sound. That's why it's called subtractive synthesizer. It's removing the sound. Okay? It's removing the sound. It's removing the sound. What do you expect it? Okay? But now we have some questions, right? Do we have to connect this sine wave directly to the filter? Oh, okay. So do we have to connect here and we have to put the filter on the output, right? Yeah, this is confusing, right? So for the answers, if you want to control the total output of this module, you like this sound. You don't need a filter here, right? You just want to filter the master output of the VCA. Then this becomes logical. But on normal situation, what you want to do is like this. You want to connect the sine wave like here. But let's go for the sawtooth, right? Now, we have designed the basic subtractive synthesizer, right? Right. So what I'm trying to do is I want to control this voltage control filter with another envelope generator, right? So what I'm going to do is I'm going to duplicate this. You can duplicate with the right click and duplicate or Command D, right? So you connect the gate output to the envelope generator. Okay. Now, what I want to do is control this filter frequency, cutoff frequency, right? So on here, you see frequency input. So uncolored hole is input. So I'm going to connect this envelope generator to see the cutoff frequency. And I'm going to increase this by like 70%. So what happened is if this was 100% and I start with here, like lowest frequency, then what it happens is whenever I click the Midi keyboard, it sends a switch on and off signal that makes the gate signal, the switch signal, look like this. So by following the Y values of this line on this timeline, right? The CV, the voltage value increases and decreases, right? Increases and decreases. So what we are going to do is sending this time-based voltage variant signal from this envelope generator to filter frequency cutoff. So what it will happen is, right? So basically, when we reach top, this filter cutoff goes here. And it goes down, 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 and stuck here until we release the key. Then the release happens and it goes here. Does it make sense, right? And if we want to control the range of this movement, we can edit this one. And if we go below minus, then this value will go down. Okay. Okay, that makes sense, right? So I'm going to do like this. Let's increase the release. Okay. Okay. Well, let's increase the sustain and we remove the decay. You see, it's going really slow down. You see this colored button? So it's still activating. Even though gate is off, it's still going on, because the gate signal ends from the sustain. And release starts from when the switch is off. When you remove the hand from the key, it activates the release. It's still going on, and if we reduce this, it'll go down, right? So today we make a basic patch of a subtractive synthesizer on VCV. We're going to cover more about this stuff and basically all these modulation things. So for friendly reminder, we're controlling filter cutoff frequency, so this is a CV information. We are not trying to hear the envelope sound that's going into the filter, right? So this is not an audio signal, this is a CV signal. And we want to control the envelope generator with a switch, so this is also CV signal. Even though we can hear the audio sound, right? It's all CV signal. Okay, thank you. I'll see you next time.